Anirudh took two metal oxides, aluminium oxide and magnesium oxide, as shown here, but he forgot to label them. How will you help him identify the oxides and label them? Aluminium oxide is amphoteric and insoluble in water. It reacts with both acids and bases. While magnesium oxide is basic in nature, that is, it reacts only with acids. Thus, aqueous solution of magnesium oxide turns red litmus to blue, whereas that of aluminium oxide does not change the color of either blue or red litmus. In an activity, Aishu was given two substances, copper sulphide and copper oxide, to obtain copper from these compounds. She was able to extract copper successfully. Illustrate with the help of chemical equations how Aishu might have completed this activity. Step 1 would be roasting, in which copper sulphide ore is heated in air, causing the sulphide to oxidize into copper oxide and releasing sulfur dioxide gas. Chemical equation for the same would be 2CuS plus 3O2 gives 2CuO plus 2SO2. Next step is reduction, in which the roasted copper oxide is then mixed with a reducing agent like carbon and then heated to extract metallic copper. The chemical equation would be 2CuO plus C gives 2Cu plus CO2. So thus copper is obtained. But to achieve high purity copper, the extracted copper is further refined through electrolysis, where impure copper is used as the anode and a strip of pure copper is used as the cathode, allowing the pure copper ions to deposit on the cathode. In the given series of reactions, name the compounds X and Z. Which type of reaction is X to Z? You are given three solutions with their pH values. You need to find out the maximum number of hydronium ions are present in which solution and arrange them in increasing order of hydronium ion concentration. Now this reaction produces sodium bicarbonate, that is baking soda, and ammonium chloride. Thus, X is sodium bicarbonate and Y is ammonium chloride. Now, when heated, sodium bicarbonate breaks down into sodium carbonate, water, and carbon dioxide. Thus, Z is sodium carbonate, and this reaction is decomposition reaction. The concentration of hydronium ions in a solution can be calculated from its pH using the formula H plus is equal to 10 raised to the minus pH. Thus, a lower pH indicates a higher concentration of hydronium ions. Therefore, for solution A, pH would be 10 raised to the minus 6. For B, it will be 10 raised to the minus 8. And for C, it will be 10 raised to the minus 9.5. Therefore, the maximum number of hydronium ions are present in solution A, and the order of increasing hydronium ion concentration would be C, then B, then A. Comment on the following statements. Bee sting is treated with baking soda paste, whereas wasp sting is treated with dilute vinegar. Baking soda, also known as sodium bicarbonate, is a basic substance that neutralizes bee stings, which are acidic. Vinegar, also known as acetic acid, is an acidic substance that neutralizes wasp stings, which are mildly basic. Farmers treat soil with quicklime while tilling. Farmers use quicklime to treat soil to increase the pH level of acidic soil, which can improve crop yield and plant growth. Ancient sculptures and marble structures are conserved by treating them with certain chemicals. Ancient sculptures and marble structures are treated with chemicals to protect them from damage caused by acids, pollution, and biological growth. Water is used by the leaves of the plants for photosynthesis, but rather than watering the leaves, we water the plant through the soil. How does this water reach the leaves of the plant. Root hairs absorb water from the soil. The water is then transferred to the xylem tissue. The xylem tissue carries the water to the leaves. Xylem tissue of the roots, stems and leaves are interconnected to form a continuous system of water conducting channels. During the day, when stomata are open, the transpiration pull becomes the major driving force for the movement of water in the xylem. Evaporation of water molecules from stomata creates a suction which pulls water from the xylem cells of roots to the stem and then to the leaves. In a family of 4 individuals, the father possessed long ears and the mother possessed short ears. If the parents had pure dominant and recessive traits respectively, and F1 individual is married to an unrelated individual of the same genotype, then calculate the ratio of the genetic makeup of F2 generation. Show a suitable cross. Father has long ears, pure dominant trait. Mother has short ears, which is a recessive trait. That means the parents have pure dominant and recessive traits respectively. Now let this be the dominant allele for long ears and this be the recessive allele for short ears. Since the father is pure dominant, his genotype is this, and since the mother is pure recessive, her genotype is this. Now, the offspring inherit one allele from each parent. Thus, his cross is this. So, the Punnett square would be this. That means all F1 individuals have the heterozygous genotype, meaning they have long ears. Now, let's see F1 cross. The F1 individual is married to an unrelated individual of the same genotype. Thus, we perform the cross and we see the Punnett square. Now, F2 generation genotypic and phenotypic ratios. So, genotypic ratios would be homozygous dominant would be 1 out of 4. Heterozygous would be 2 out of 4 and homozygous recessive would be 1 out of 4. That means genotypic ratio is 1:2:1. Now let's see the phenotypic ratios. Long ears would be 3 out of 4 and short ears would be 1 out of 4. That means our phenotypic ratio is 3:1. In the F2 generation, 75% of the offspring will have long ears and 25% will have short ears. So this is what the conclusion is. And this follows Mendel's law of segregation, where the recessive trait reappears in the F2 generation in a 3:1 ratio. If father had short ears and mother had long ears, and both the parents are homozygous for the allelic pair of genes, explain what effect it will have on the ratio of genetic makeup in F2 generation if F1 individual is married to an unrelated individual of the same genotype. Let's assume ear length is determined by a single gene with 2 alleles. Since both parents are homozygous, their genotypes must be these. The F1 individuals are now crossed with an unrelated individual of the same genotype. A typical monohybrid cross between 2 heterozygous individuals follows this Punnett square. Thus, we can say the genotypic ratio in F2 generation would be 1 homozygous dominant, 2 heterozygous, 1 homozygous recessive. Thus, 3:1 is the genotypic ratio. Now let's see the phenotypic ratio in F2 generation. 3 long ears and 1 short ear. Thus, the phenotypic ratio is 3:1. We can say when a F1 heterozygous individual mates with another heterozygous individual, the F2 generation exhibits a 1:2:1 genotypic ratio and 3:1 phenotypic ratio with 75% long-eared individuals and 25% short-eared individuals. What is the fundamental difference between hypermetropia and myopia in terms of the optical experience of a person? The fundamental difference between hypermetropia and myopia lies in how light is focused on retina and how it affects vision. Let's first discuss myopia. The eye focuses light in front of the retina instead of directly on it. Distant objects appear blurry, while close objects can be seen clearly. This happens due to either an elongated eyeball or an overly curved cornea or lens. Concave lenses are used to shift the focal point back onto the retina, whereas in hypermetropia, the eye focuses light behind the retina instead of directly on it. Nearby objects appear blurry, while distant objects remain clear. This is usually due to a shorter eyeball or insufficiently curved cornea or lens. Convex lenses are used to bring the focal point forward onto the retina. So, the key difference is that a myopic person struggles with seeing far objects clearly but sees near objects well, whereas a hypermetropic person has difficulty with near objects but sees distant objects clearly. The diagram below shows a special case of an eye defect. What is the defect that is shown in the figure? State one cause for such a defect. Explain with reason if a concave lens can be used to correct the defect. Now, we can see from the figure that here the light rays focus behind the retina. This indicates that the image is formed too far back in the eye, resulting in blurred near vision, a key characteristic of hypermetropia. This defect arises either because the focal length of the eye lens is too long or the eyeball has become too short. Now, can concave lens be used to correct hypermetropia? Well, the answer is no. That's because the concave lens would diverge the rays coming to the eyeball and will push the image even further. So, a convex lens should be used which will help to converge the rays and create the image at the exact place on the retina. State the relationship between the resistance R of a wire to its length L and cross-sectional area A. Use the mathematical symbols to arrive at the final formula. Using the formula, define the resistivity of a material. R is directly proportional to L, where R is the resistance and L is the length of the material used. Now R is inversely proportional to A, where A is the cross-sectional area. R is rho times L upon A, where rho is the resistivity of the material. That means rho would be equal to R into A upon L. If area is 1 meter square and length is 1 meter, we get rho equal to R. Thus, we can say resistivity is the resistance offered by a wire of length L, 1 meter, having a cross-sectional area of 1 meter square. Mona was doing an experiment with a magnetic compass and a straight current carrying wire. She observed that as she moved the compass away from the current carrying wire, the deflection of the compass needle reduced. Explain why the deflection of the compass needle reduced as Mona moved away the compass needle from the current carrying wire. Also, Mention one thing that could have changed in the circuit of the wire that could increase the deflection of the needle, and explain with reason what will be the direction of the magnetic field associated with the wire for the case described by the given figure. A current carrying wire creates a magnetic field around it. The magnetic field strength decreases as the distance from the wire increases. The compass needle aligns itself with the magnetic field lines. As the compass moves away from the wire, the needle aligns less with the magnetic field, leading to reduced deflection. Now, one thing that could have changed in the circuit of the wire that could increase the deflection of the needle can be increasing the current in the wire, as that would increase the magnetic field strength, thus increasing the deflection of the needle. Next is, explain with reason what will be the direction of the magnetic field associated with the wire for the case described in the given figure. The battery suggests that the current is going from top of the plane to the bottom of the plane. Now, using the right hand thumb rule, we can say that the magnetic field will be clockwise.